Hello everyone, I'm Mallesh Koram. Welcome to AK Competitives, and we are going to discuss IITJEE physics. In that, the first chapter what we are going to do is going to be ray optics, and in this first video we are going to start with the introduction part to ray optics. Let's get into the topic without wasting the time.
So optics. Then what is the optics? Optics is a branch of physics where we are going to discuss about light. Okay, then what is the light? Light is a form of energy which gives us the sensation of vision. What do you mean by the sensation of vision word? Okay, then sensation of vision is nothing but, so if I am able to see this pen, I am able to see just because light is going to incident on it and reaching back my eyes. So that is the reason why I am able to see this. In case if it is not happening, so I will not be able to see this. So any object we are seeing, so two types of things will be there. One is self-luminous, like which are going to produce the light. Maybe like a electric bulb, or maybe like sun, maybe like any kind of stars you are going to see are going to be one of the example. The other side are like light from other source incident on it and reflects and reaches to our eyes. So that is the like moon or any planet or any kind of object which is not going to produce the light. So these are the other kind of things. So but ultimately light from that object should reach our eyes in order to see this. What are the properties of light? Because we are going to say optics is a branch of physics where we discuss the light, then it is important to understand the properties of light. So first property what we are going to say, light is a electromagnetic wave. The first property what we are going to say is light is a electromagnetic wave. Then what do you exactly mean by electromagnetic wave? Okay, then let me draw a small diagram here to make you understand what is going to be electromagnetic wave. I'm going to take one axis like this, another axis like this, another axis like this. Okay, so x-axis, y-axis and z-axis. I hope all of you are getting. So these three are the axes: x-axis, y-axis, z-axis. Okay, these are the three axes what we are considering. Now if you are going to see, light is going to move in which direction? In the direction of what you can call it as x-axis. If the light is going to propagate towards x-axis, then how the electric field and magnetic field are going to move? So these electric and magnetic fields are combined towards each other. Like this, they are going to oscillate, like electric field is going to oscillate like this as the wave propagates in this way. This is the velocity vector. As a result of that, electric field is going to vary according to this. So as the wave moves like this, electric field is going to oscillate in upward direction. That is the primary thing. And secondary fact, you need to understand about magnetic field. How the magnetic field is going to oscillate then? Let us try to understand here by thinking about the magnetic field here. Magnetic field is going to be oscillating in like this. Okay, then as the electric field is going to oscillate up and down, magnetic field is going to oscillate out and in. Like this, the magnetic field is going to move. So this is the basic idea what you have to keep in mind in order to know about electromagnetic wave. So in this diagram you can see clearly, as the electric field is going to move like this, then magnetic field B bar is going to oscillate in this direction. It comes like this. So these two are what you say like interconnected with each other. As you can see, suppose if the wave is going to move in this way, as the electric field go from 0 to maximum, magnetic field comes from 0 to maximum. As this comes back to 0, this comes back to 0. Again, as it goes and comes up, it will go inside and come outside. So this is a basic scenario what you have to keep in mind in order to know about electromagnetic wave. And one more property you will see here, light moves in a straight line. Light moves in a straight line. So in a medium, actually, I just want to define the medium, but for the time being you understand this definition, then I will come back to that point. So light moves in a straight line, and this phenomenon is called as rectilinear propagation of light. Light moves in a straight line. This phenomenon is rectilinear propagation of light. Then when light enters from air to water, like it changes the direction. Like as it incident like this, then it may be going in the other direction, like going to bend. Like if it is incidenting like this, then it will not go straight, it will bend. So this is the phenomenon called refraction, what we are going to discuss after the reflection in this particular lectures. But here we are going to consider in one medium, then it moves in a straight line. That path followed by the light is called as ray. Okay, path followed by the light is going to be called as ray. That also will come to that particular point. And light in space, light in free space moves with a speed of 3 into 10 to the power 8 meter per second. Okay, 3 into 10 to the power 8 meter per second speed. And this is the ultimate speed possible in the nature, because light is going to move with ultimate speed. There is no object which can move faster than light in the nature. C plus V should be taken as a C only. Then what is the light speed in any medium? So again, you have to keep one point in mind. In vacuum or free space, light moves with this ultimate speed. Into any other medium, speed of light will be lesser than this particular speed. How much it will change, that we'll discuss in the next refraction part, where we are going to concentrate on medium concept also. There I will tell you what you exactly mean by optically rarer, optically denser, all these points I'll tell you when we start with the refraction. Then, as we say, light is a part of electromagnetic wave. Electromagnetic waves, we have a separate chapter. We will discuss there in detail, like from all the points, like what are the key points, what are the properties, what are the uses, what are the disadvantages, everything will concentrate over there. But at this moment, we are not going to look at all, but we are going to see where exactly light stands in electromagnetic spectrum. And we'll move to the next point. Okay, see the spectrum once. So spectrum, you can see that. So from gamma rays to what you say like a radio waves, all is going to be expanded. This leftmost side gamma rays, rightmost side you will be having radio waves. Then here, what are the properties? How will change? So actually, let me tell you one point here. So first, whatever light we are going to say, this is our concentration. This itself is light. This itself is light. Only that particular section of what you say like electromagnetic spectrum is going to be called as light. Okay. Then in this light only, we will be having violet, indigo, like all this Vijaya. Human eye is basically having more sensitive towards yellow and green light. So that is the reason why we'll be able to see that area more compared to other lights. And as you go on the either sides, sensitivity of eye will be decreasing. So when we discuss about eye, persistence of eye and all those points we'll discuss again. So here we are not getting into detail. Then what are the limitations? So before saying you the limitations, I just want to tell you one point. As you go this side, as you move towards this side, energy and frequency increases and wavelength decreases. As you go this side, high energy, high frequency, but low wavelength. That is the point what you have to keep in mind. And what happens if you go on the other side? On the other side, if you go, then two things will happen again. Energy and frequency decreases. Energy and frequency decreases, comes down. What increases here? Here wavelength is going to be increased. Wavelength is going to be increased. So now higher the wavelength, lesser the energy. Lesser the wavelength, higher the energy, also frequency. Okay, then what are the values of for this light what we are going to discuss now? So here lambda of minimum, because this side minimum, right? Minimum wavelength we are going to define. Other side we are going to define maximum wavelength. So lambda minimum, which is going to be approximately 400 nanometers. Nanometers is 10 to the power minus 9 meters. So that all of you are familiar. So no need of going more details into it. So now lambda maximum is going to be what I can write 780 nanometers. Okay. Now 400, 780. So this is the range of light what we are going to discuss. This itself is also called as visible light. Okay. Then you have two relations. Frequency F is equal to C by lambda and energy E is equal to HC by lambda also you can write. So if you know lambda, you can calculate energy ranges, you can calculate frequency ranges, all these things we can be able to do that. Let's go to the next point. Next point is branches of optics. Optics is not a small topic because it's going to have vast range, because the history, even if you're going, so it is having almost 400 to 500 years of history which is going to be produced clear evidence. And before that people struggled and people tried, but there was no considerable a science which was developed. But this 500 years almost the science development was rapid in optics, and this optics can be divided into certain categories. What are those? We'll see now. Okay, so basically optics is having three branches. So optics is having three branches. So the first branch itself is going to be called as ray optics, and second branch is going to be called as wave optics, and third branch is going to be called as quantum optics. First branch is ray optics, second branch is wave optics, third branch is quantum optics. So this ray optics is the branch of optics where we are going to discuss light on the concept of ray, okay, on the concept of ray. And this wave optics is the branch of optics where we are going to discuss light on the concept of wave. And the third one, quantum, which is going to be based on quantum mechanics or quantum theory principles, which is going to be a complete theory which is going to be different. Okay, these are the three categories we can do, and sometimes all together this ray optics and wave optics together we can call classical optics, and this quantum optics we can call it as modern optics. Are you able to understand? Ray optics, wave optics together called as classical optics, and quantum optics alone we can call it as modern optics. So now here these two together we call them as going to be classical optics. Classical optics. Okay, then this particular one which you are going to have as quantum is called as modern optics. Modern optics. Okay, then classical, modern. Why? Because the quantum mechanics one is going to be came in 19th century, where people based on that quantum mechanics the optics developed, which is called as quantum optics. And as we are not that much familiar with the quantum theory at this level, that is the reason why we cannot discuss that quantum optics, but we can go for these two, what you can call it as one is ray optics, other one is wave optics. These two concepts we are going to discuss in this particular level. Okay, this is the point. So now let me tell you what is ray optics. Ray optics. So ray optics is also having another name called as geometrical optics. Geometrical optics. So now ray optics or geometrical optics, why the names came like that? So now let me just tell you here a key point. So first let me give you a diagram. Suppose if I have a torchlight, some kind of torchlight if I have. Okay, if I switch on the torchlight, how the light moves? So if I switch on the torchlight, then light is going to move straight away like this. Okay, the path followed by the light is called as ray. Already in before part I told you this definition even. So path followed by this light is going to be called as ray. Okay, so light when you switch on, it will not be only one ray, right? So there will be bunch of rays. That bunch of rays is called as beam. Are you able to understand? Bunch of rays is called as beam. So when you have a bunch of rays, we can call them as a beam. Let me just draw the diagram here so that you can understand it clearly. So now this is a beam. So now in this beam, how that particular rays are moving? All are moving parallel to each other like my fingers. So each one is going to be parallel to the others. Then you can call that type of beam as a parallel beam. Are you able to understand? So this is a parallel beam. Now there are two other types of beams. I'll just define here, then we'll go to next one. So another one is going to be a beam where the light rays may go away from each other. This is called diverging beam because the light rays are moving away from each other as they are moving. So this is called diverging beam. Okay, diverging beam. Then in the same way, let me firstly define what you can call the third type. Third type is going to be converging. Converging beam. So now we have a limitation actually when we can discuss about ray, when we can discuss about what you can call it as a wave. So before getting into it, let me tell you what is wave optics, then we'll jump to that part. Okay, then here, so here let me tell you based on ray concept, if we discuss the optics, ray optics. Okay, then what is geometrical optics? then why we can call it as geometrical optics? So simple reason. So in any problem which you're going to solve in geometrical optics, any this ray optics, any derivation which you're going to do, mostly we are going to use the geometry of the diagram. Like based on the geometry principles, we are going to develop this part. That is the reason why we are going to call it as geometrical optics. Okay, nothing more than that. Geometrical optics. Okay, then. Now next one we need to understand about wave optics. Then what is a wave? So first we need to understand the same kind of diagram again. So for that, let me draw same kind of torchlight. When you switch on, what is going to happen? So then again light moves like this, but this time you will not assume it is like a straight line which is moving, but you're going to assume a wave is going to move in that path. Then if a wave is going to move, how it may propagate? It may propagate like this. Wave is a kind of disturbance which carries momentum and energy. Already you might be knowing the definition. So wave can travel like this. Okay, then based on the wave concept, if you discuss, then that is called wave optics. Are you able to understand? So hence we are going to call this as wave optics. So this wave optics is also having another name called as physical optics. Physical optics. I hope all of you are able to get it. So physical optics. Then what do you mean by wave optics or physical optics? Simple logic. So where the wave nature must be considered, so that particular part we are going to discuss in this particular optics based on quantum principles. When you explain, that is called as quantum optics. So but that we are not going to touch at this level. Let's go to the next point. Next point, as I told you, limit of ray optics, like where you can use ray optics, where you have to use wave optics. That is the clarity just I want to give here, but mathematically we'll come to this point when we go to wave optics, but here I just want to give you a fundamental idea. So how we can discuss about that, I'll tell you here. So let me draw the small diagram in order to demonstrate you what exactly I am trying to say. So now let me draw a small diagram here. So like an object I'm going to keep which is having size D, and I'm going to have a wall just for the reference. Okay, I'm having an object like this pen, I'm going to keep it like this, then I'm going to have a wall behind it. So when I'm going to switch on the light from here, light exactly goes and touches the wall. So which is below part will not move because it hits and stops here only. It creates a shadow, and above part is going to be illuminating the wall. Then how it is going to look like, I am going to show you in this particular diagram. So just have a look at this. So now above this level, all light rays are going to move as it is and illuminating the particular part like this. And below rays are going to be stopped and forming shadow. Okay, so that below part is going to create a shadow. Now what happens in the other case I will tell you. So now here this is the case for D is going to be very much greater than lambda. What is D? Size of the object. Size of object. And now what is lambda? Wavelength of light. So is it true? Is it possible that light is going to be having a wavelength which is much smaller than the what you can call it as size of the object? Obviously. Why? Because if I take the nib of this pen approximately 1 millimeter or 0.5 millimeter, and now if I'm size of this, and if I'm going to see the light wavelength 700 nanometers from 400 nanometers. So now 400 to 780 nanometers when you take, it is in the order of 10 to the power minus 7 meters. So 10,000 times bigger. The nib of this pen is going to be 10,000 times to the wavelength of light. So very much bigger. So the ray concept can be utilized and we can be able to discuss under ray optics. Okay, concept of ray can be used. Why? Because light moves in a straight line, it doesn't bend. That is the reason why we can use the ray concept. And the other part, when size of this particular is going to be different, like let me tell you here for your clarity, if D is going to be incomparable to lambda or D is going to be smaller than lambda. So when you go to at atomic level, when you go to what you can call it as domain level, size of the object is itself is going to be comparable to wavelength or maybe smaller than that. Under that case, light, what happens to light? Let me draw the same kind of diagram once again. size object here which is having size as d, and behind this I'm going to put a wall. Okay, now if you take the light, how it is going to move, then usually the light we expect to be moving straight only without bending. Okay, and above lights as usual this illuminates and there is no difference in it even at this point, and before this are going to be stopped here, there is nothing different. Okay, then what changes? So this point which is going to be hitting at the edge is going to bend like this instead of going straight. Now some part of the geometrical shadow is going to be illuminated by the light. Okay, this region is going to be illuminated with the light. This part is going to be geometrical shadow, but light illuminates geometrical shadow. So this is the way what is going to tell you the basic idea where you have to bending phenomenon is not possible for wave, so definitely it should be for a wave. So wave concept should be considered at this point in order to discuss this. That is the reason why you can call this as wave optics. I hope all of you are able to understand wave concept. So wave optics. So you have to use, and here you have to use ray concept, ray optics. So this is the condition for ray optics, and this is the condition for wave optics. So again, mathematically we can have a formula which we are going to discuss in wave optics as I told you. Okay, at this point this is enough, and let's move to the next point. Nature of the light. Then what is the nature of light? In order to understand nature of light, two possibilities are there for nature of light. What are the two possibilities? One is a particle, other one is going to be a wave, particle or a wave. So two things are only possible, particle or a wave. Based on this, there are few theories. Quickly we'll have a look at it, because this is again having a huge history. We are not getting into detail to it, and we are going to discuss straight away. So let us take a ladder on which we are going to say based on the history, like from the beginning to ending, which is related to classical. Just will touch at the end what is going to be quantum, and we are going to stop it. Okay, now see, the first ever theory which was developed on optics is going to be by Newton, and which is called as corpuscular theory. Okay, the first theory is Newton's corpuscular theory, according to which he said light is going to be a particle, but this particle is having mass but very much smaller, almost negligible, and this is what said by Newton, and Descartes even accepted it. And in the same century, like maybe 20 to 30 years later, Huygens is the person, Christian Huygens is another person who came up with another idea that light is going to be a wave, and he said his wavefront theory called wave theory. But due to Newton's fame, nobody accepted that theory in the scientific world, and that was kept aside almost for 100 to 150 years, when Thomas Young is going to be person came up with a beautiful experiment called as Young's double slit experiment, which is going to be our topic for the wave optics. Okay, there we'll discuss in detail what is done by Thomas Young, and as it explains what you can call it as wave nature, like interference phenomenon by using wave nature, then everybody got once eye-open kind of situation, where people stopped believing on this corpuscular theory and they started digging into wave theory, and it gave a very nice result, like all the phenomena, reflection, refraction, polarization, diffraction and interference, everything got a clarity, and everything was accepted as a wave theory for light. And later, few years later, again Maxwell came up with another theory called electromagnetic wave theory. Okay, electromagnetic theory said that it is a kind of unification theory even. So it is having most important thing, because electromagnetic waves and light were treated to be completely different phenomena. But suddenly, at this point of time, he said that both are going to be same, and theoretically provided the speed of light formula, which is experimentally also found. And later Hertz is the person who produced electromagnetic waves experimentally and provided the proof for Maxwell's wave theory. Now suddenly Hertz himself he observed one phenomenon called photoelectric effect, where he tried to answer with the help of what you can call it as electromagnetic wave theory, but unfortunately he got failed. He was not able to explain with this theory, so there was no solution. So in 1899, Max Planck came up with another theory called quantum theory. Again he said it is a particle, but this time it's a packet of energy. It is not going to be a particle like what Newton said. It is a particle like what you say, massless energy packet is called as a photon, which you can call quantum. Okay, now, but same thing happened with the Max Planck also. What was happened with the Huygens? So like nobody believed him. So then few years later again, Albert Einstein came up and took this quantum theory and tried to give the answer for Hertz's unsuccessful story, which is going to be about photoelectric effect. What do you mean by photoelectric effect? When light incident on a metal, then electrons eject, current will come out. That is what the principle for our solar panels at nowadays, and even you might be knowing about it in chemistry. So we'll discuss when we go to modern physics in atoms, and before that dual nature we are going to discuss in detail. Don't worry about it. Okay, so let's go to the next point. What is the next point? Object. So basically object is nothing but whatever object, because these definitions are going to be important in optics. So we'll discuss these quickly and we'll move to the next one. So object is nothing but the intersecting point of light rays before the incident on some surface is called as object. Objects are of two types. One is real object, the other one is going to be virtual object. Okay, one is real object, other one is going to be virtual object. Now here how it is going to be, like suppose before incidenting on the surface, if the beam is going to be a diverging beam, then you can call it as real object. Like real object actually exists and the intersecting point, all the light rays are actually meeting at that point, then it is called as real object. Look at the diagram. For all the types of mirrors I have given you here, for plane mirror, for curved mirrors, all the three I have given you here. So how it is going to be looking like about real object. All the three beams are going to be diverging beam from that intersecting point. And now if you go on the other side for the virtual object, then you can see there, so like the light beams is going to be converging beam. And one more important fact you can observe, so actually the light rays are not meeting at that point, they appear to be meeting, but actually they are not meeting. So like this for curved mirrors also, you can just have a look at it, and this is the way how you can define real object and virtual object. I hope all of you are able to get it, and this is the idea about object. Let's move to the image. Image is the point of intersection of light rays after reflecting or refracting from the like any surface. Here we are going to start off with the reflection, so let us consider reflection only. So after reflection, where the light rays are going to be intersecting, that point is called as image. Again, if they actually meet, real image. If they appear to be meeting, then virtual image. That's it. That is the simple idea. And two types of images will be there. And now like converging diverging case will become reverse, and you can just have a look at it. So now you will be having a converging beam before the reflection, like virtual object is going to be there on this side. So now this is virtual object. So when after the reflection, you can see here, so after the reflection they are going to be meeting exactly at this point. So this is going to be real image. So virtual object, real image. A plane mirror is having this property. You might be already learned in the case in 10th standard when you have studied the optics. Okay, go to the virtual. Now, so virtual image, when you want to discuss, you can see here clearly light is coming from a real object. And incidenting on the mirror. After reflection, it is going to be a diverging beam. Now, when rays are going to be diverged, here you can call it as virtual image. So for diverging beam before reflection will be having real object. Diverging beam after reflection is going to give you virtual image. So plane mirror is having exactly opposite nature. Like for real object, it creates a virtual image. Virtual object, it creates a real image. So now this is a virtual image, and this is real object. One more thing, a real image can be traced on a screen like projector, which you are going to put on a screen, but a virtual image cannot be traced on a screen like you are going to see in a mirror. Yourself is going to be the best example.
I hope all of you are able to understand this lecture, and if you like, then like the video and share the video. Please don't forget to subscribe the channel. Thank you all, and we'll meet again in the next session.